Hello students, welcome to another video of calculus. Today we will discuss the steps to find the range of the function. So, in like the previous video we have find the domains of given function. Now in this video we will find the range of given function. So, to find the range of the function we have some steps are given. So, the topic is steps to find steps to find the range of the function. There are three basic steps. By following that steps we can find the range of the given function. So, to find the range of the function find the range of the function we have some step. First step is put y is equals to f of x. We have, if we have given f of x is equals to something, then we have to put y is equals to f of x. Second step is solve that y is equals to f of x. This we have to find, we have to solve this. Suppose this y is equals to f of x for y instead of x. Solve x instead of y. Solve x instead of y, and the third step is the range of given function f is the set of all y such that x can, for which x can be solved. The range of f, range of the given function f is the set of all real numbers, is the set of all real numbers y, is the set of all real numbers y such that x can be solved, x can be solved. Using these three steps we can find the range of given function. We will solve some examples that will make it more simple. So, the first example is, for each of the following functions find the range. For each of the following functions find the range. So, the first function is f of x is equals to x square plus 2, f of x is equals to x square plus 2. We does not have here, we does not have given any domain and codomain. We have to find the range in real numbers. So, here f of x is equals to x square plus 2. Using these three steps we can find the range of given function. So, first step is put y is equals to f of x. So, we will put y is equals to f of x. Here we have given f of x is equals to x square plus 2. Now, we will put y is equals to f of x, which is equals to x square plus 2. Now, we get y is equals to this x square plus 2, that is this y is equals to x square plus 2. Now, second step is we have to solve x instead of y. Here y is equal to something, we have to solve this equation for x, because that means we need x is equals to something. Now, first of all we will just separate the term x. So, x square is equals to this y minus 2, x square is equals to y minus 2. Now, taking square root we get x is equals to plus or minus square root of y minus 2. Taking square root on both sides we get x is equals to plus or minus y minus 2. First step was put y is equals to f of x. Here y is equals to f of x. Now, second step we have to solve the given this equation for x instead of y. Here y is equals to x square plus 2. We have to rearrange this equation in the form of x is equal to something. So, x is equals to plus or minus square root of y minus 2, and third step is range of the given function f is the set of all real numbers y such that x can be solved. This means that we have to find this for which values of x this function is defined. For which values of x this right hand side is defined, that is just we have to just find the domain of this function. This function means domain for this square root of y minus 2. Like the previous video we have seen these examples of square root. The domain of this square root of y minus 2 is y minus 2 is greater or equal 0, that is this x is defined in real numbers whenever this y minus 2 is greater than or equals to 0. We have to find the range of the function f. The range of the function f is the set of all real numbers y, set of all real numbers y such that x can be solved. We have to find the all values of y for which x can be solved. X can be solved means x can be a real number. So, this x is a real number is possible only when the term which is under root, that is y minus 2 must be greater than or equals to 0. If this y minus 2 is less than 0, then square root of negative number is not possible in real numbers. So, this function, so this x can be solved for values of y which is y minus 2 whenever y minus 2 is greater than 0. So, we can write this x can be solved, x can be solved if and only if this y minus 2 is either greater than or equals to 0, that is y is greater than or equals to minus 2. So, this is the range of the function. Therefore, the range of the function, this question can be asked for 2 marks in the university exam. The range of the function f, given function f is set of all real numbers for which y is greater than or equals to minus 2, sorry, y is greater than or equals to plus 2, that is the range of the function is open interval 2 to infinity. This is the range of the given function. Now, the next example is similarly we can solve the next example. Second f of x is equals to 1 upon x minus 3, 1 upon x minus 3. Now, similar like previous example, we have given f of x is equals to 1 upon x minus 3. We have to put y is equals to f of x, which is equals y is equals 1 upon x minus 3. Now, we have to solve this whole equation for x. So, we can rearrange this by multiplying both sides by x minus 3, or just putting this term and rearranging this equation, we get sorry, if you take the reciprocal, then we get 1 upon y is equals to x minus 3. We have to find the value of x minus 3. So, if you take the reciprocal on both sides, then we get 1 upon y is equals to 1 upon x minus 3, 1 upon x minus 3 is x minus 3. We have to find x is equals to something. So, x is equals to this minus 3 will become plus 3. So, 1 by y plus 3, x is equals to 1 by y plus 3, and this x can be solved, that is the value of real number x is possible only when y is a non-zero number. If y is equals to 0, then 1 upon 0 is infinity plus 3 will become again infinity. So, if y is equals to 0, then we cannot find the value of x in real number. So, we have to find the value of all real numbers for which this x can be solved. We have to find all values of real numbers y for which x can be solved. So, this x can be solved only when y is non-zero. So, thus we can write x can be solved. In short, we have to find the domain of right hand side of this equation whenever this will be a real number. So, x can be solved whenever y is non-zero. Therefore, the domain of given function, sorry, domain not domain, range of the given function, the range of given function f is, range of the given function f is y belongs to R, set of all real numbers for which y is non-zero. We can write this as minus infinity to 0 union 0 to infinity. This is the range of given function, or we can write it as R minus singleton 0 also. This is the range of given function. Now the next example is f of x is equals to square root of 1 plus 6x, 1 plus 6x. Here f of x is equals to square root of 1 plus 6x, and we have to put y first step y is equals to f of x, that is y is equals to 1 plus 6x. We have to solve this example, we have to solve this equation for x. If we square on both sides, then we get, if we square on both sides, then we get y square is equals to 1 plus 6x. Now this plus 1 will become minus 1 in this side. So y square minus 1 is equals to 6x. This implies x is equals to y square minus 1 by 6, y square minus y square minus 1 by 6. Now we have to find, the all values of x for all values, for all values of y, for which values of y x can be solved. So here x can be solved for any real number y. We can clearly say that if you put any real number, suppose if you put y is equals to minus 1, then minus 1 square is plus 1, 1 minus 1 is 0, so 1 upon 0, sorry 0 upon 6 is 0. So therefore this x can be solved for all real numbers y, for all real numbers y. Also one thing must be clear, that if we put, suppose y is equal to some minus 1, then it is possible to get the value of square root of 1 plus 6 is equal to some minus number. Square root of some number is equals to minus number. Yes, because if we take the square root of 4, then 2 minus 2 will be also square root of that 4, because minus 2 square will be 4. So this x can be solved for all real numbers y. That is, therefore the range of the given function is, whole real number r, that is all real numbers. Now we will see some definitions. So the next topic of our chapter is graphs of the function. Graphs of function. In this the first topic is type of functions with their graphs. Types of function. In this topic, the first point is types of functions. So the first definition is constant function. Constant function. Constant function means image of every element in domain is equal to some constant, that is a function or a constant function, f from suppose real number to real number is given by f of x is equals to c, or some c belongs to R. F of x is equals to, that is image of every real number is equals to that particular number c, then the function is called, this function is called constant function. The domain of the given function is R and the range of the given function is only c. If we put, suppose f of x, if for example f of x is equals to 2 for all x belongs to R, then their graph will be, suppose this is y axis, this is x axis, this is y axis, then for every real number, suppose this is 1 and this is 2, for every real number the range will be 2. If you take f of 1, then f of 1 will be again 2, f of 2 will be 2, then f of 3 will be again 3, f of 4 will be again 2, sorry, f of 4 is equals to 2, f of 3 is equals to 2, f of 2 is equals to, if you take f of 1 by 2 for, this is suppose 1 by 2, f of, sorry, this is 3 by 2, f of 3 by 2, then f of 3 by 2 for the constant function is again 2. If you take f of 1 by 2, then it is again 2. So, this is the range, sorry, this is the graph of given constant function. Constant function means if every element in the domain maps to same element in codomain, then for that function we say that the given function is constant function. This is the graph of given function. Now, the next definition is a linear function. Linear function. A linear function, the function of the form ax plus b. A linear function is given by a linear function f is given by f of x is equals to ax plus b, where a is non-zero number and both a and b are real number. A is non-zero real number, b is also real number. So, function of the form ax plus b is said to be a linear function. For example, if we take f of x is equals to suppose 2x plus 3, then their graph will be, suppose x is equals to 0, then we get, suppose this 1, 2, 3, this is 0, this is minus 1, minus 2 and so on. So, here 0, then this is 1, this is 2, 3, then f of 0 will be 0 plus 3 is 3, then f of suppose minus 1, if we take f of minus 1. So, f of minus 1 minus 2 plus 3, minus 2 plus 3 is plus 1. So, f of minus 1 will become plus 1. Now, suppose f of 1, f of 1 will be 2 plus 3 is 5. Suppose this is 4, this is 5, 3, suppose 4, this is 5, this is 4, then f of 1 will be this. Then the graph of the given function is a straight line passing through these points. So, this is the graph of given function, sorry, given linear function. This is 2x plus 3 line. So, for particular example you can find the graph. Now, means linear function means the function of the form ax plus b, whose the function given by ax plus b is called linear function. Now, the third function is quadratic function. Quadratic function. A quadratic function is given by the function of the form ax square plus bx plus c is called quadratic function. A quadratic function is given by f of x is equals to ax square plus bx plus c, where a is a non-zero real number, b, c, that is all a, b, c are real numbers, but a is non-zero. Function is given by this is called quadratic function. Also, the domain of given function is R and codomain is suppose a greater than 0. So, to find the graph of the given function, graph of the given quadratic function is like this. So, if you plot the graph, then the graph will be like this. For any particular example, for any particular values of a, b, c, the graph will be like this. Just suppose this is y axis, this is x axis, then the graph of the given function will be like this. Now, this is the quadratic function. The next definition is polynomial function. Now, we will see some more definitions. The fourth one or fourth definition is polynomial function. Polynomial function, a function of the form f of x is equals to a n x raised to n plus a n minus 1 x raised to n minus 1 plus up to a1 x plus a naught, where this a naught, a1, a2 up to an all are real numbers and an is non-zero. This for this a naught, a1, a2 up to this an all are real numbers and an is a non-zero. It's called polynomial function. We are familiar with these functions since 11th 12th we are studying the polynomials. So, polynomial function, this is called polynomial function. Now, we will see some other definitions in the next lecture for rational function, exponential, logarithmic. The definitions we will see in the next lecture.